In late June 2026, an AI agent encrypted over 1,300 production database records, installed persistent backdoors, and left a ransom note, and not a single human touched a keyboard. The agent that did it was called JadePuffer. It's what security researchers now call an agentic threat actor, an attacker whose capability is delivered by an AI agent, not a human with a toolkit. It targeted a production MySQL server running Alibaba Nakos by exploiting a critical vulnerability in Langflow, a Python AI package with over 100,000 GitHub stars. Langflow hit that milestone in August 2025, 10 months before the attack. Here's what makes this a nightmare. The AI adapted to failures in real time, going from a failed login to a working fix in 31 seconds. When it hit errors, it debugged itself. It built 6 working Python scripts in just over 5 minutes. When an API request returned XML instead of JSON, the next payload adjusted its parsing logic automatically. No human stepped in to fix the code. The agent read the error, updated the parser, and retried. Like watching a developer work through a bug, except faster. And it gets worse. If the attacker was running this agent on stolen AI credentials through LLM jacking, the marginal cost of the entire operation was close to $0. No skill required, no compute bill, infinite retries. The economics just broke. So let's break down exactly how this worked. The entry point was CVE 2025-3248, an unauthenticated remote code execution bug in Langflow with a CVSS score of 9.8, critical. That's the second highest severity tier. Anything above 9 is drop everything and patch. The vulnerability lived in a code validation endpoint. It accepted unauthenticated HTTP requests and passed attacker-supplied Python directly to the interpreter. No authentication check, no sandboxing, just exec. Any string you sent became running code. JadePuffer sent malicious Python to the Langflow endpoint and got immediate code execution. From there, it scraped environment variables, found root credentials for the MySQL server, and established a reverse shell. Classic privilege escalation, fully automated. Then it pivoted laterally to the MySQL server and exploited CVE 2021-29441 in Nakos, a 4-year-old authentication bypass that creates rogue administrator accounts. The Nakos team patched this in 2021. The victim was running an unpatched version in 2026. It installed a cron job configured to beacon back to attacker infrastructure every 30 minutes for persistence. Then, it encrypted 1342 Nakos service configuration items, deleted the originals, and dropped a ransom note with a Bitcoin address and Proton Mail contact. The entire operation, reconnaissance, exploitation, lateral movement, persistence, encryption, cleanup, took under 10 minutes. Fully automated. No operator intervention between the initial prompt and the final ransom note. But here's where it gets weird. The encryption key was generated from 2 random UUIDs, printed once to standard output, and never saved or transmitted anywhere. The attacker has no copy. If a victim paid the ransom, they'd get nothing. The data is gone forever. The key lived for exactly 1 line, right here. 2 UUIDs get hashed into an AES 256 key, printed once, then used to encrypt. After this print statement, it vanished. No exfiltration, no persistence, no recovery possible. The agent never considered long-term memory. This puts JadePuffer in the same category as NotPetya, the 2017 wiper that caused $10 billion in damage by masquerading as ransomware. Encryption as cover for destruction. Whether JadePuffer's flaw was intentional or an AI mistake, nobody knows. Security researchers call it nihilistic ransomware. And then there's the Bitcoin address and the ransom note. It's 3J98TEZ73CNMQV, the canonical example wallet from Bitcoin developer documentation. Exactly the kind of string an LLM would hallucinate from training data. Except that wallet isn't inert. Blockchain records show it's handled 737 confirmed transactions and roughly 46 Bitcoin over its entire history. That's about $2 million at 2026 prices. So, is it real, or did someone fund a meme address after the fact? The ambiguity is perfect. We can't tell if the AI copied documentation, picked a real wallet by coincidence, or if the attacker manually edited the note. That uncertainty is the new normal with AI-driven attacks. Now let's talk about how preventable this was. A GitHub user named Liu Tun opened issue 696 on July 27, 2023, identifying the unauthenticated RCE endpoint. Langflow finally patched it on April 1st, 2025, 22 months later. CISA added it to their known exploited vulnerabilities catalog on May 5th, 2025. The JadePuffer attack happened in late June 2026, over 14 months after the fix shipped. The victim was running an unpatched Langflow instance exposed to the internet with cloud credentials and environment variables. 3 catastrophic mistakes. Langflow instances remained exposed on the internet with minimal hardening, often containing cloud credentials and API keys. The Nakos server used an authentication bypass from 2021 and default signing keys. Every lock was old and unlocked. Before JadePuffer, a botnet called Flodrix had already exploited the same Langflow vulnerability in June 2025. The first ransomware attack run, start to finish by an AI, didn't use a single new technique. What made it notable wasn't sophistication. It was that an AI model strung together years-old CVEs, default credentials, and standard lateral movement into a complete operation without human intervention. Automation, not innovation. Here's why this changes everything. Sysdig's Michael Clark, Senior Director of Threat Research, said, quote, "We have seen attackers script attacks for years, and we have seen AI speed up individual steps. However, this attack was driven end-to-end by the model's own decision-making, rather than a human at the keyboard. That's the distinction. But a human still chose the victim, built the infrastructure, and provided the stolen credentials. The debate isn't whether it was fully autonomous, it's whether that distinction even matters when the skill floor just collapsed to prompt engineering. Traditional ransomware required deep expertise in reconnaissance, lateral movement, persistence, and encryption. An operator needed to understand network architecture, database schemas, authentication flows. JadePuffer required none of that. The barrier to entry is now whatever it costs to run an agent, and if that's stolen compute, it's free. The real threat isn't that AI makes elite attackers more dangerous. It's that AI makes non-elite attackers capable of elite tradecraft and makes the marginal cost of trying so low that no exposed system is too small to be worth attacking. The long tail of victims just became infinite. This is a democratization event. Ransomware was once the tool of organized cybercrime groups, names like Revel, Conti, Lockbit. These groups had budgets, infrastructure, money laundering operations. Now it's a capability anyone with API access can deploy at scale. The bottleneck is gone. Compare the operational requirements. Traditional groups needed skilled operators, custom tooling, command and control infrastructure, and money laundering pipelines. AI-driven attacks need prompt engineering and stolen API keys. That's it. The infrastructure collapsed to a single API endpoint. 3 things to remember. 1. JadePuffer was the first end-to-end ransomware attack driven by an AI agent, adapting to failures in real time like a human. It went from failed login to working exploit in 31 seconds. It debugged itself, adjusted to unexpected API responses, and wrote 6 scripts in 5 minutes. 2. The encryption key was never saved, making it a wiper disguised as ransomware. Payment would recover nothing. This is not Petya all over again, except this time an AI wrote it by accident, or maybe on purpose. We don't know, and that's the problem. 3. It exploited vulnerabilities from 2021 and 2023, proving AI doesn't need 0 days when humans leave old doors unlocked. The victim was running unpatched software 14 months after the fix. JadePuffer didn't break in, it walked through unlocked doors. Sysdig disclosed the attack on July 1st, 2026. As of now, it's unknown how many other AI-driven intrusions have occurred, but haven't been detected or haven't been disclosed. JadePuffer is the first one we know about. It won't be the last. The skill floor collapsed, the cost approached 0. Every exposed system with an old vulnerability is now a target. Patch your stuff, or let the robots do it for you. Wait, that's how this started.